So there are a number of very interesting applications. One thing that we do a lot of is called MapReduce. It's an algorithm which is publicly known. It is part of a mechanism for putting large numbers of processors to work in a kind of sorting and organizing process. You map a lot of the comparison activity to a large number of machines, and the ones who find things report that they found something that matches, and then the whole system reduces down. And that's why when you do a Google search, you see, only 10 million responses coming back instead of 100 billion of them. Then comes the other problem, which is figuring out in what order to place them in there, and we use an algorithm called PageRank, which has evolved over the last 10 or 11 years, some of the details of which I won't tell you because they're they're trade secrets, because we don't want people to artificially modify the data in order to artificially inflate their PageRank. It's important to us that this be an unbiased system. So the data center world has this very, very large potential to allow us to process data and to flexibly allocate resources, whether they're storage or processing, as the need requires. There are all kinds of issues. You face these every single day, and the folks who have been trailblazing for NEAM, these are all things that they wake up with or have to deal with every day, like data definitions and the metadata that goes with them. How in the heck do I manage to preserve security across multiple implementations of the database? How can I get people to agree to actually interwork with clouds? I mean, some people say, it's my cloud, you can't have anything to do with it. My reaction to this is kind of like the stovepipe problem we have, not just in the federal government, but in every large organization. It's my data and you can't have it, or I'm not interested in helping you with yours. We need to figure out how to find motivations for people to want to participate. NEAM is no exception to that. We need to find both, I think, benefits, like your system will work better if you use this particular technology, or threats, as your budget will be cut off if you don't do it this way. And that's often a very powerful argument. The thing that I would like to see happen, quite honestly, is that we achieve zero technical barrier to the interworking of our information. Now, if we want to prevent certain things from being exchanged and accessed by policy, fine. But I don't want the technology to be the barrier. I want the policy to be the barrier. So if the policy changes, the technology can adapt. And I cannot say, and could not emphasize more strongly how important that is. Get rid of the technical barriers, deal with the other things on a purely policy basis. So I'm going to come back to just a few sets of issues. One of the things that will be helpful to you is to have a lot of use cases in mind as you think about how to adapt and to apply NEAM technology and how to integrate that into cloud environments. Figuring out how to build APIs so that the data that we do define in the NEAM fashion can be easily accessed and manipulated. One question that came up in a group that was meeting about inter-cloud interactions was what's different between just interactions between time-sharing systems and interactions between clouds, and that's actually a fairly interesting question. You could trivialize cloud interaction, because today what happens is that when you go to Google, you are talking to a cloud, but it doesn't look any different than talking to a time-sharing system. The question, though, is when you have clouds talking to each other, you have the potential of a huge magnitude of exchange going on, moving, literally dynamically moving processes from one cloud to another. It's very different from the kind of simple client-server style of time-shared systems that we're all familiar with. So here's a few examples of strategy and tactics that I would urge on you. First one is solve problems people don't know they have yet. Get ahead of the problem space if you can. Now, some of you don't have that option because the problem has been around for a long time, and it's represented in the form of existing databases that you have to accommodate. But the idea that interoperability is important has not necessarily occurred to some people who have databases that they're using very effectively in their local activity, but it may not have occurred to them that that information might be useful and important to other people. So using NEAM as a way of getting ahead of that recognition and realization would be very valuable. The second thing I've learned is that in order to make progress, you have to ask the right question. It's often hard to solve a problem if you pose it the wrong way. If any of you are mathematicians, you'll remember this notion of a change of variables. Sometimes you look at an equation and it's very, very complex and you can't figure out how on earth to cope with it. A change of variables literally rewrites the form of the equation, and sometimes in a way that makes it obvious how to solve the problem because it's been represented in a different way. Sometimes that is an important way of making progress. Get the question right, and the answer may stare you right in the face, or at least guide you in the direction of where to go. One thing which has occurred to me is that when we're thinking about clouds and this very large capacity for storage and processing, that in addition to the exchange notion that NEEM, boy, this thing always gets in the way of your hands, doesn't it? Bang, bang. The exchange notion is buried, of course, in the notion of NEEM. But one interesting possibility is integration. What would happen if we could take things that are expressible in NEEM and we pour them all together into one gigantic database? And now we have more flexible opportunities to manipulate that information in the big table MapReduce sense, for example. So I actually get excited about that for a number of reasons. In the intelligence community, there's a natural practice to compartment everything. The side effect of compartmentation is that if there are correlations among those various compartmented databases, you can't see them. It would be very interesting if you were allowed to pour all that data together into one thing and then make access control on the outside determine who can and can't see those correlations. But at least the machine has the opportunity to compare and detect potentially important correlations in the otherwise compartmented data. It's likely that a lot of the data that you deal with could be intermingled with other data to reveal things that we wouldn't otherwise see. We see that happen in Google Earth because the organizing principle there is geographically indexing. And when you see multiple data sources, all of which are organized geographically or by time or some other really strong organizing principle, you begin to see correlations that you would never see, except that they got presented in a way that is immediately visually correlatable. So the big table and MapReduce are just examples of large-scale use of computing power spread over a large number of processors, well beyond the kind of traditional large-scale mainframe tactics that have been more common in the past. I would say that evaluating high-profile use cases to accelerate the appreciation for the NEEM idea is a good idea. So health records and smart grid energy information and intelligence data are examples of high-profile information which would benefit from this kind of correlation and commonality that NEEM can supply. And finally, to offer advice to people who've been in Washington like I have for 33 years, today you need to get Anish Chopra and Vivek Kundra on your side. The last thing in the world you want is they're not on your side, particularly Vivek, who's a wonderful guy, but if he says, you know what, if you can't do this, your line item doesn't show up in the president's budget. That's a really powerful argument. I can tell you that it worked really well for me when I was at DARPA, and I told everybody that it was time to move off of the ARPANET protocols and into the TCP/IP internet protocols. And people were saying, well, why should I bother doing that? My email works, my file transfers work, my remote access to time sharing works with Telnet. Why should I bother with that? And I said, oh, this is really simple. I'm going to cut your budget to zero next year if you're not running TCP/IP. Oh, okay, that makes sense. And off they went. Now, unfortunately, there are 700 million machines on the internet, and you have a bazillion different organizations. You can't quite pull that shtick anymore, but the guy who has his hand on the budget tiller has a whole lot of persuasive power available. So don't forget that in addition to all the technology and everything else, you may have a friend on your side as long as he believes in NEEM. And so if you haven't already proselytized, you might want to consider that as a next step. And with that, I'll stop and I'll invite questions, and I'm happy to engage in conversation. Thank you very much.
If you have questions, if you'd like to come to one of the microphones in the front of the room, we'd enjoy that.
I don't want anybody to get nervous when I run off the stage and run up to the microphone. I'm hearing impaired. Sometimes I have to lip read. So we'll try without that, and if it doesn't work, I'm going to run around like Geraldo. Yes, sir.
Yes, Dave Elisandy, National Laboratories. Clouds and ESBs and all of these big data sources are real
sorry,
popular.
I'm going to stop you for a minute. The lights are so bad that I can't see you, so I'm coming down on off stage.
Okay.
Can we have the house lights up? There he goes.
Okay.
Let there be light. Yes, sir.
It's important to realize that when you're transmitting between clouds or between these different things, that there's a policy structure associated with each. And, you know, NSA and other people are allowed to build cryptographically strong devices. Does the federal government or anyone that you know of realize the need for when they do these policy transitions between clouds, they need to build a policy structure and a device that can, because that's a trust anchor that you're actually establishing between the two.
Yeah, actually, it's a really good example of a gotcha, for instance, as you move from one environment to another. A lot of it, that's exactly the point about the access control question that comes up. As you move from one policy regime to another, what to do about that. Some of us have been looking at the general problem of interconnection among systems. And when we used to draw pictures of the Internet as a bunch of clouds that got hooked together, and the problem was, how do I provide a commonality of things like addressing and routing? When we started talking about policy, we said, well, what if we had a collection of systems that all had adopted the same policy, however it was expressed, and we had a set of different systems that we wanted to interoperate? How do we describe the interactions between the two so that they have compatible, they only exchange information that's compatible with the policies that they both observe? And so your point is precisely well taken. You can easily contort that, though, into a we ain't letting you communicate at all know-how. That's not a good outcome. The outcome needs to be the ability to figure out how to make that work and the policies enforced. Yes, sir.
Ivan Handler from the Illinois Department of Healthcare and Family Services. I'm the CIO. I'm very happy to be here and excited. One of the things that's happening now, you're probably aware of, is that there's the ONC wants us to build these health information exchanges pretty rapidly. That's being kind. And one of the issues that we're facing in Illinois, and I think many states, is to conceptualize how we're going to do this is hard enough. To think that we're going to build out all this stuff is probably crazy. Where I think the cloud computing becomes very important is that a lot of the things that we're talking about in terms of exchanging data is probably more appropriate to the cloud. It allows states to share resources rather than the feds having to put money into every state easily. But distinctly. But I'm not seeing. I've already talked to somebody in Google. We're not seeing a lot of interest. It's a huge market opportunity, but it's quite different. I think it's not Web 2.0. It's not exchange of data for consumer items. It's production level data, high security. I think the issue you talked about, having the ability to look at data from different silos to see correlations, but to provide the security. That's all very exciting stuff, and it'd be nice if there'd be some way or somebody that could help stimulate that, because we don't have a lot of time. And we have a lot to do.
It's the time. Thank you for that. And maybe after we're done, we can chat a bit more. One of the things that I have been very worried about as I watch the energy of this administration towards making things happen quickly is that you run into the potential hazard of ready, fire, aim. And one of the most scary things about the area you're in is that adopting a set of things as standard, as infrastructure, locks you in for a substantial period of time. It's really, really hard to undo standards. And there are backwards compatibility questions and a whole bunch of other things. How do I evolve in a way that doesn't destroy my ability to access data that's been around for a while? There are all those questions that come up. So doing this in a way that is not fatal, I guess, is really important from my point of view.